All right. Welcome everyone at the Multi-Network Community Sync. Today is September 13th, and today I just want to go over the changes that I did for the Phase 1 CAP doc. Um, and basically what I was kind of thinking how to do this the best way. So I would like to go through the doc through the whole doc today. And I was thinking too, if you have any question about the cap, I will just interrupt me. I will try to answer. But if the discussion is gonna be longer than like let's say half a minute, uh, just leave the let's leave. I will just leave myself a comment, and then we can continue offline, or you can leave the comment as I speak. I just want to go over the doc, what I did, but still, I assume I would appreciate if everyone could just read through it offline, just word by word, and like if any wording is wrong or anything, please just correct, comment, what's not. This is a joint effort. It's not like just mine doc, so please feel it and own it on your side as well. All right, let me just share the doc. And the link to the doc to follow me is on the top of the community minutes. Is the first link at the beginning of the. If you want to follow with me and just not interrupt me and just add your own comments as I go, then yeah, go can do like that. All right. So basically, what I did here is just gonna go through some of the changes. So terminology, goals. I think goals need to be kind of unified with what we have. I haven't did that one, so that probably has to be unified with what we have because I'm going to add this doc to the existing requirements cap. So this has to be unified with this one and the other. The terminology didn't change. In the background, I added semi kind of explanation about network. And the explanation is that the purpose here of it is that we don't want to define a network. We just want to ensure that network is a represent is has some representation in Kubernetes, but what it means is up to the implementers kind of will, right? On how what defines a network. So we don't want to put any definition like on it. Just it is defined by whoever implements a pod network, and then that's how they basically then treat a network as. Um, so that just gonna clear that out of the way. Then the next is the CNI usage. I think I mentioned that the two models, the standalone and the agent-based. I'm not sure whether those are the correct names. Someone maybe probably tell me. Maybe there are some already definitions defined. But basically, the one from the difference between the two is the agent with the CNI communicates with API server. So that's the main kind of purpose of this. Um, and that's the background section. And now it's in overview. I'm trying to kind of define in short what we're doing here. So introducing the two new objects, adding the controller, adding validation for those guys, and some modification for the default network. And here a relation. I'm trying to kind of point out a relation how the new objects, the pod and pod network, pod network and pod network attachment relate and how they behave against the pod. And I kind of put it in a graph, but as well kind of described it in here. So basically, things like pod can reference multiple pod networks, can reference multiple pod network attachments. Pod network can point only to one pod network, so on and so forth. You can have one of either pod network or pod network attachment for a specific pod network. I tried to describe it like this over here, so please read through it with kind of offline and see whether that's if I missed something or maybe something's not understood. It's too complicated, so help me with maybe wording it better or presenting it in a better way. So there is that part. Um, and then going to the design, let me maybe show, because I usually like going by the outline on the left. Let me just show those guys off. So basically going by outline. So first I'm introducing the new resources that we talked about. I think there's not much change here. The pod network, as we defined, as we talked, which has those IPAM objects and then parameters reference and the optional provider. Some examples how those would look like with some conditions and some parameters. Then the conditions themselves, because we have the conditions. So condition status is ready, params ready, and in use, with explanations. That hasn't changed. That's exactly how I written it, had it initially written. That stayed. And then the provider wording, what is the use case of it? Basically, that is used for the implementer. It is defined and presented for the implementers to be kind of if implementations want to be coexistent in a single cluster, they could use the provider to do that. The IPAM fields. This is explained to kind of identify what they are used for. And there is a mention about the Kubernetes type that it will not be introduced in this phase, right? So we will introduce the APIs, but we will not implement a node IPAM that's built in this phase as well. So that will have to be a separate cap. Which has to come up after the cluster cider stuff is resolved. And then mentioning about our discussion about one IP, that a pod network has to be represented by one IP per family, and this is to be to contain the backward compatibility. We don't want to change that one. Next one is the in-use indicator. So how that works, basically through the condition, we will put a finalizer on the object when the in-use is set, and basically the finalizer will block the deletion of a specific pod network. And then because this is going to be set as soon as there is at least one pod or a pod network attachment pointing to a pod network, right? So when that happens, we will put that the pod network object is in use, and there is additional condition. I think I'm not sure who, but I had a comment on how far we will which pod we will pick up for this, and basically we will filter out succeeded pods. So succeeded pods basically are done when those run a job and are done and they are not running anymore. So the containers are basically deleted and the namespaces. So I am thinking of filtering out the succeeded state pods to kind of not call the network just because there is a job that just finished, right? So filtering out those guys. Now about mutability for the object, that basically the whole thing is immutable. You will have to recreate it from scratch if anything. Then there is a small caveat around the IPAM fields where if not specified, you can update them, but when they are set, you cannot change them anymore. And this is basically same behavior as some of you might be familiar with the pod cider of a field in a node, basically the same type of a behavior. And basically, of course, if there's any additional kind of admission control for the object, implementations can add more stuff. Like, for example, checking what is the referenced parameters file, whether it's correct or not, that kind of thing. But that's on the implementation side. Life cycle. I'm not sure whether this is correctly said, but basically in life cycle, I try to kind of how the object is going to behave to describe that. Not sure whether that's understandable, but please read through it. But in a gist, you can create an object. It's without any conditions, and basically nothing can attach to it. Object is not ready because the validation failed, or there is maybe there is a parameters reference this set, but the controller on the other on the implementation side didn't set the params ready condition, and basically this is not ready. Pods cannot attach in this state, right? If it's not ready. Ready, basically everything, all validation passed, and now pods can attach to this pod network. Then there is some pod running, so basically the guy is the pod network is in use, so that now we can still attach, but pod network cannot be deleted. Delete in progress, so basically case where someone ran a delete on the pod network, so that means the delete timestamp on the object is non-zero. In that case, we will set the pod network to not ready, and so no new pods will be able to attach to such pod network because it's in delete in progress, right? So no new pods will be able to be attached to this. And then lastly, this is deleted when in use condition is not present or false. And then basically we can just delete the object. That's more or less the life cycle of the object, how I would envision it. Please read through it, and again, help me if there is any, it's not fully clear how that should work. Any question? No. Okay, moving on. Pod network attachment. Here is the definition is as we said, but I am describing as a pod level of parameters into the pod, right? With basically just two fields, the pod network name and the parameters reference, and as well the conditions. So I am copy pasting whatever I just described for pod network to pod network attachment. Same story. So basically that means that the statuses are the same, plus one more. One more is the pod network not ready. So basically if attachment is the pod network attachment pointing to a pod network that is not ready, we will indicate that, right? So basically the pod network is not ready, a failure, right? So that's additional reason for not ready of the whole global condition. But the rest is similar. There is an in-use indicator where at least one pod is using this guy, and of course same thing. We will filter out the succeeded state pods. Then the whole pod network attachment is immutable. So basically you set it once and then you have to recreate it if you want to change something. Life cycle is similar to pod network created. I think the only change is there any change here? No, I don't think there's any change against a pod network. So the life cycle is very similar to the other guy. Basically, there is that, and that's all about the pod network attachment, right? Please read through it. I just want to make sure that we have the kind of the functionality of the object properly defined, and please help me read through it if that's really reflect what it is, if there may be, or can it be better kind of expressed. Moving on, now I want to introduce the default pod network, and this is basically what we discussed. I haven't changed much here. The default pod network, the one thing is that kubelets, I think I did mention that before, but I'm gonna say it again, that I want to change kubelets, and I have a section for kubelets changes there to kind of react and discover, check whether that default pod network exists, right? So basically that's one aspect of this. Deletion prevention. So basically, since default is a network that always has to be there, similar to the default namespace, I discussed with some folks on how to kind of achieve this. And I think the way to do it is, considering we currently are going to use the finalizer to prevent any direct deletion of a specific object, The way we're going to handle the default network, on the other hand, is that as soon as someone is going to try to delete that object and the delete timestamps field is set, we will just recreate the object immediately. The way it is, we will just delete it, remove the finalizer, delete the object, and recreate it immediately. And that's I'm planning to do this in API server, where basically this hopefully will be set and caught. So that's basically how I'm trying to prevent the deletion of the default network, and preventing the default network to be in the delete in progress state, because we cannot have that, right? I see there's some chat. Check. Oh. Because we cannot have the default network be in delete state, because it always has to be available. So that's the way I want to achieve that. Similar to default namespace, it always has to be there, and basically we will just copy paste the existing object if it's being deleted by someone, and recreate it. So that's the goal here. Now when I think about this, if what about so if what if someone deletes the parameters, right? If I have my default network has parameters and they are deleted or something, so that's I think at that case I've just described that the um, infrastructure providers will have to ensure that the custom object is always there for the for the default network to be present. I will just call it out in case someone has a reference parameters inside the default network, and someone can delete that one, right? So that's up to the implementers to ensure that it's always there's a default network for the default network to be ready. That's not something that we can cover. Okay. Going on, this is automatic creation. So basically how we would migrate existing cluster to pod network and ensure that the default network is there. So there is the whole description. We will leverage the existing arguments of KCM, and how those would translate to a default network. So this is, I think, all the possible combinations. And for some folks that maybe not aware, those are the flags that you can set for KCM, and basically then we expect some things, and based on that, there will be the node IPAM taking part. The node IPAM, that's basically part of the KCM, and it will do basically node configuration of the CIDRs. This is the pod CIDR field that I mentioned before on the node. So basically, this is how we this is the Kubernetes basically mode that says that yes, I want to use the node IPAM, which we are initially will not support. But for default network is basically there and support. So basically that's why if you specify a CIDR and allocate node CIDRs is true, we say the IPAMs are for both in this case because there are two. There is v4, v6. So we say those two guys as Kubernetes. So this is the default network. This is a case where only one is set. So basically in this cluster you will have only Kubernetes for v4, but nothing for 6. One aspect to those guys, I think I did I skipped that to let you know that, and I think I extended the description in the spec of this pod network object, is that IPAM as well indicate the requirement of IP. So if I have specified in IPAM 4 and 6, like in the above here, there is Kubernetes, I expect to receive a IP, respective IP for that pod network, in that pod for that pod network. This is something that initially will not be enforced, but eventually when we have CRI catching up and being able to return us the name of the pod network the specific IP belongs to, this is where we will enforce this. So maybe let me because I missed that detail. So that aspect, I need to add that, missed that. So that's another detail. The case where basically 1v4, I think I mentioned that, but there is a case where, for example, someone doesn't use this at all, right? So in this case, we would just probably there won't be any spec even. We will just create a, or maybe there will. Oh, it will be like this. So basically, in this case, we will create just empty, and then I would imagine the installer of the mm, cluster, the kind of provider of the cluster, if they do support pod networks and they want to do some additional stuff here, they have means to now update this post creation, right? Or as well update maybe basically that, right? So they can update this field. And there's another flag to all this where maybe the providers will just use the manual creation of the object, right? So basically, there is I'm thinking of introducing this guy into KCM that will just prevent the creation of the default network completely, and then it will be up to the installer of the cluster to create it by themselves. So basically, define some YAML and apply it initially when the cluster is being created. With the caveat that kubelets will report a default pod network not found if until it's there, right? So that will be kind of the gate, similar to like CNI config path today is checked on every node to kind of indicate that the node is ready. We want to kind of add this additional condition for that aspect. Uh, Network migration, this is for a case where, oh, how do I change my default network? As I said, pod networks is immutable. So how do I migrate from one to the other type if something has to change? And there is some idea. It will not be part of this phase, the implementation of it, but there is some idea of how to do that in the future. We do this because this is in a line of one of the other requirements that we have in later phase, which basically covers similar use case where we want to override the default pod network for a namespace. So this will be this kind of following similar idea, but overriding the default pod network on a node level. And this is how we could leverage and introduce the migration story here. All right, moving on. So now, as I mentioned, we want to have for this whole thing a pod network controller. This will be additional controller in the KCM component of upstream Kubernetes, and it will have those three functions, basically handling the conditions for our two new objects, handling the finalizer, maybe conditions includes, maybe I will just do that, maybe just say all conditions, because that as well includes the in use and ready. Those two conditions it is going to handle. And lastly, it will handle the whole automatic creation of the default pod network. So that's this guy is going to handle all this. Then I do mention that we're going to introduce the new feature gate for this feature. It will be called multi-network, and everything will be behind this gate. Then the aspect of another API changes, aspect of attaching pod network to a pod. So basically, this is where what we discussed, how we envision this. I changed the name. Before this was named pod network attachment. I just switched to networks. I don't know. Let's see what the rest of the community is gonna tell us. But I think someone was mentioning those queues networks, and I just went for it. So in pod it will be networks. Uh, we'll see, and basically single object is called network. So we will have a structure with that name to introduce by this. We'll see how that goes. This is just a field in the pod spec, so let's see how that will work out. Then inside we have the standard things. The one thing that did change is the primary name. Now it's called is_default gateway. This was I think Wim. Oh, Wim is here. Yes. So basically, Wim proposed default gateway. I added the is, and this is where we ended. If you have other proposals, let us know, and that's we can talk about this. But that's the current proposal. And as basically to describe those fields, those are mutually exclusive, either pod network or attachment. You specify one of those two for each network structure. Then interface name, this is just basically what is going to be the interface name of the pod. I am adding for the additional fields a sentence where that this field functionality is dependent on the CNI. So basically and its support for it. So it's not something that we can enforce. So whether those last three fields work, it's up to the kind of implementation, how they are going to be used.
Maciej, do you want to just say is dependent on implementation and the support for it?
Yeah, probably.
Yeah.
Thank you.
Also, it's default or the pod network, is it? If you don't list the pod network, you get the default.
Oh yeah, I'm gonna get there. So I will let me finish. Yeah, it's all. Yeah, let me. Okay, need to fix this. So then those are I think about the fields. That's this. Then this is example of how that would look like, right? Then I am mentioning two validations for this. First will be the static. I'm calling them static, and then the other one is active. So the static validation is basically I have the pod spec and what can I check. So this will be done in the API server. What I heard, this is where generally that kind of webhooks are done for the core objects. So what we are going to do is ensure there is just single pod. Ensure a single pod references a given pod network only one time. So I want to introduce that rule, and I have explanation for that rule down below here, meaning that why we adding that rule to be more restrictive now, and if anything in the future we can loosen this up, but that's in the gist. So it will check for this. Check that either one of those two guys is unique with the true value across all the networks objects. Same for the interface name. It has to be unique across all the networks if it's specified. And then interface name has to have a kind of apply the constraints for Linux and Windows. Oh, yeah, this is it. So networks objects should not be specified when host network is set. So there is that. This is a small tidbit that I think we never discussed about this, but this kind of feels straightforward, right? If host network is defined and networks are defined, we should fail. You should have only one of those. They are mutually exclusive, right? Then going to active validations. So those are validations. Those characterize themselves that I try to apply a pod with something wrong, I will get an instant error, right? That's what static validations are. Active validations, you will not have that. You can apply the incorrect spec, and over time you will see, oh, my pod doesn't start up. What's wrong? So basically, the error will be presented as a pod event, and basically those active validation require additional objects. So basically, I need to pull something from API additionally to do the validation, right? So this is what I'm calling active validations. So in this case, for example, I will see whether the referenced objects are even present, exist, or then are they ready? And lastly, there's still, because there is an aspect of still to apply that rule that I'm here ensuring a pod reference only one pod network. I cannot do this directly from the pod network attachments. So the only way I can do it, because I need to pull the pod network attachment, see which pod network it references, and then I can check across whether that's all correct or not. So I'm pushing that into the active validation. So if someone uses a pod network attachment with a pod network that is used again in some directly or with some other pod networks, that will be done only over here. So that will be a active validation and presented as a pod events. So read through that, think about this, but I think this is what I'm proposing in terms of the additional validation. Let me know if I missed something in terms of what, is there any other case for the spec that we need to test, but I think I covered most. And this is where the, now moving on, is the auto population. This is, I think, Kevin, that you were referring to. So when this field is not set and the host networks is not set, right? So those two conditions, we will just populate this. We will set pod networks, and this will be done similar, like scheduler sets node node name. I think field there's a node name or something like that, which basically indicates which node the specific pod is going to be run. You can manually specify that, but if you don't specify it, scheduler will pick one for you and it will set it. Same with this. If you don't specify networks, I will populate it with pod network name default. And basically this will just a small mutation webhook or something like that. That will just add this guy into the pod spec. I think that's Kevin. That's what you were asking, right?
Yeah.
Okay.
That's it.
Status. So basically pod status changes. So I'm calling out, we want to expand, there's a structure called pod IP, and we want to expand it with those two additional elements. So currently we have only IP. I want to add a pod network name. And then it will have as well interface name. And basically better to look at it from the exact kind of spec here, because there are two fields. There is a pod IP, which is the old very first field that was created. We cannot do anything about this. This is just a string. So that's behavior for that guy doesn't change. Maybe slightly, because now this will hold the this is a bit tricky, so we will see whether that's okay. So basically, what I'm calling out this is pod IPs, where the change, because that one pod IP, this is a list of struct, which I'm changing. And there is the pod IP singleton, right? The string. So this thing will hold the primary pod network of the pod, basically the one that said I am the default gateway, but for the preferred IP family. There is, if I'm not mistaken, there is a preference in the cluster to say which IP is primary, or I'm mistaken. I think I'm mistaken on this one. This definitely is a thing for services, but it's not a thing for. Now, when I think about this, this is something that I think. So maybe that's a tricky one right now, because we allow to disjoin the default gateway for v4 and v6. So this might be a tricky one. So I think we still, unless we just always do v4 in this IP, maybe that's the case. We always set v4, so maybe that's then easy. So we always only set v4 for that one, unless if it's a dual stack. Unless it's a single stack v6, then we just a single stack, we will write the primary of that single stack. So maybe that should be, yeah, that should be the. Let me check on that. That might be the case here. So that's one aspect of this. And now going to the pod IPs themselves. So basically you have, for those reference pod networks, the pod IP, as I mentioned, is the default because do we have that defined? We did not. But basically, so let's say this is the default because the default network is here. And it's, I think the order here, I don't think we're gonna kind of do something about the order. That will be probably up to the CRI, how they return this to us. But what I would envision, it will be just having IP assigned network to it and what interface was chosen, right? Because it doesn't always have to be the same, right? It can be completely different name because of something, right? So maybe let's just do this because I think I'm missing.
Hey Mache,
Yes.
question for you about this comment on the pod IP struct. An IP address allocated to the pod, routable at least within the cluster. To me, that sounds like it's that it must be routable within the cluster, which I feel like
this is a copy paste. This is existing
oh,
code.
that's from the existing. Okay.
So maybe that
So
has to be changed. That's a fair point. Let's do this.
yes, yeah, awesome. Okay, very good. Awesome. All
Because
right,
I
yeah.
bolded out the new things because this is a copy paste from the code. Yes, I see. That's a fair
Now
point.
I
Yes.
follow. Yeah. Awesome. Yeah. Thanks for addressing that. Yeah, awesome.
IP already exists, right? So those are the two new things we would add, and plus some description. I probably need to add a interface name is missing. All right. So there is that. Not much left. We are almost at the end. So any other questions to the status? I think this is covered. All right. So there's that. And basically, I'm describing the case that it's supposed to be the kind of populated by kubelet. But this is something. This is dependent on the CRI kind of catching up. I think initially this will be all up to the implementations to populate these fields, right? So initially it will be we will be dependent on the CRIs to kind of provide that. So until that's done, we cannot have anything about this, right? So the fields will be there, but it will be not populated until CRI catches up. I am mentioned DRI here to define that we did look into that kind of model. And that was in aspect of pod spec changes, but because of user experience, having explicit pod network model proposed here fits better the needs. This is a networks. Yeah. So I am mentioning that we had a kind of we consider DRI to be reused here. And now just a short kind of list of what kind of summary of the changes introduced, right? So we will have an API server changes that will do the webhooking for validation webhooking for pod network and pod network attachment. This is the static. I call them static validations. I described above. And it will as well handle the deletion of the default pod network. So basically, when someone accidentally delete default pod network, we will just recreate it. And then it will as well have the changes for the pod spec validation. No, that's yeah. So basically, we're webhooking for those two guys. I think the pod network and pod network attachment, I haven't touched on this. Maybe this should be more in terms of what validation we're going to do. I think I never put any details on this. Yeah, I will add that because I think that's completely missing. There is no details about what sort of validation we plan to do. It's just calling this out here. So let me just add details on that. I think I mentioned about the default pod network deletion and then extended pod spec validation. I did mention this is the static validation for pod spec, right? Scheduler changes. So this is where do I have this right? Yeah. The one thing that the scheduler will do is do the active validation of the pod spec. So I was considering where to place it, and after some discussion with teammates, I think we're gonna propose to do it in the pod scheduler. Like example, today when pod requests some resources and those don't exist, a scheduler will just put the pod in pending state. So I just want to follow the same pattern with this, right? So basically, scheduler will do the whole active validation. I think. Oh, I think it was this. And basically here I'm describing what's going to happen. So, and this is the example I provided with the resources. This is exactly what is being done. So if something fails in terms of those validations, we will set a pod scheduled condition. There is that name condition in the pod. It will be set to false with the message that something is wrong with the pod spec. And of course, if there will be an event on the pod stating that, I don't know, pod network data plane doesn't exist, right? Something like that. So we will leverage the same means to kind of block and put the pod in the pending state when, for example, a specific pod network doesn't exist. So we want to leverage the scheduler for that work. And I'm squinting here a bit. We'll see how the upstream, we need to talk with the scheduler folks and the API server folks to see is that okay for us, or should there be some other means, or we will hear their recommendations where will the best place to do this. So there is that. Kubelet changes. So this is all about the default network, right? So I am describing how Kubelet today checks for the CNI config presence. This is going, if I'm not mistaken, this is done through a CRI call. But on top of that check, we will let Kubelet check whether a default pod network is found. If it's not, then we will just say default pod network not found in API, and make the node not ready. So ready conditions will be touched, and it will be set to false until the default pod network is not found. Oh, I could find a case. Should we handle a case where someone deleted the node, the pod network? I wonder. Since we have the means in API server to always restore, maybe not, but something to consider. There is this, and then the interface. So I have two separate sections though. Kubelet CRI interface, and I'm kind of describing that the API for that interface from the Kubernetes side is the V1 pod, which we change. So we provide all the required data for the CRIs already. What needs to change is the CRI APIs. And I'm calling out it here, what sort of changes needs to be done, at least what I'm expecting that has to be done, and then that it's going to be a separate cap. So this cap will not cover the CRI changes for this. And below, I have some proposals on what could change, what should change to have this done, right? For those 3 items that I listed. But this is again just a proposal for not part of this cap, where we will not touch any of that. And that's it, folks. Basically, there's appendix of what the DRA, additional DRA integration could look like, and we have some other discussion on the SRV, so how that could look like with configuration for Multus, but those are just additional notes. In terms of the opens that we have here, the RBAC The RBAC, something that we discuss, is going to be pushed to the next phase. So that's something that we will tackle in the next discussions. How to support multiple IPs per family. That's another thing. I think this is not in our requirements. So this is something that probably I'm just gonna push back, because this is a new just feature request for Kubernetes in general to support multiple IPs per family per interface. We don't do this today for default network neither. So that's why I think that's a just we don't have that even in the requirements. And I think that's it. Yeah, we managed 50 minutes. Okay, it took me the whole hour. Please, folks, read through it. I just went very brief across this. I would like you all to read it word by word and see whether this is all correct. Please help me refactor so that the wider group understand this better. So if you don't understand it, there probably is going to be another person who will be in the same bucket as you. So call that out here in the doc. Please comment so we can rephrase, or maybe something you don't agree with. So let's change something. But please review. I would like to set an end date for this reviews so that I can post this as a PR. But I think before I post the PR, I think the PR can be posted. But before we going to ask for like reviews for the folks, I think we need to do the road trip with this presentation. So my next goal is to kick off those slides with what we are proposing with all the changes, so that we can then easily point everyone to this CAP and review that. I think that will be the next steps. Any other comments? Speechless.
There's a lot of work went into that.
Yeah,
yes,
totally.
All of our work, yes.
And
so
there's been a ton of discussion to lead up to this point for sure.
Mm-hmm.
So yeah, thanks for taking that 50 minutes to go over the whole shebang. So yeah, it's appreciated.
Yep. All right, folks. If we don't have any other topics, we probably can end it at this. Anything to add here? I think I'm gonna. I saw Pete, you doing some hackathon to try to implement this. Now I think you have some draft you can work off of. I got some pings from Cyrus, right?
So yeah, that's right. So there's a few of us are just going to try and do a very basic hackathon project. What we're going to do is add the new objects to Kubernetes and then play around, probably with changing Multus so it can use them, and just see how far we get.
Right.
A lot of people on it, frankly, have, including myself, have not built Kubernetes before, and I've not got that much experience of doing some of these low-level things. So we're learning a lot. I don't know how far we'll get. We'll have fun, and yeah, whatever we end up with, we'll make public afterwards. I suspect what we'll end up with is just something that's created probably all of the new resources, but not written any of the controllers. I think that's a reasonable thing to expect us to have. So yeah, that might be useful, and if it's useful, then we will pass it over.
Yep, definitely. I think if you were to integrate with the new model of Multus, which I think connects with API and then pulls the pod as well, I think then you will have all the data right from the pod. And instead of looking at the annotation, just look at the
exactly. Yeah, there's a little bit more because you have to go and read the pod network resource as well and get the information out of that. So there's another spot of indirection, but it's not a huge amount. It feels like it's an achievable hackathon. I'm halfway through the week doing it part-time in my spare time, as is everyone else. So I'm not sure whether it's feeling less achievable as the week goes on, but you never know.
Yeah,
we're in the middle bit.
I am only interjecting just because I'm excited about this, but Pete, needless to say, I'm pretty excited about this, and I'm really interested from all aspects of it, and including the workflow to make the modification and build Kubernetes and then lay modified Multus over it all sounds awesome. And I mean, I feel like I will personally benefit from what you learn. So yeah, if you need a brain to pick or whatever, yeah, feel free to ping me as well, and Tomo, and yeah, we can try to add some insight on the modifying multi side at least. Yeah, super cool. I'm pretty excited
Yes.
about it. So thanks, Pete.
Yeah, thanks. It's certainly been fascinating so far. We've learned a lot of stuff.
Yeah. Yeah,
But
and,
it'll be good. It'll be good to have an implementation, even if
definitely.
it's an implementation that's written in my code, which is not the best. It'll be good to have something we can point to and say, here's a way.
No, yeah, that will show us any gaps as well, right? Because maybe we are missing something crucial, and,
Yeah.
and that will give us some feedback or right away. Yes, that's definitely
Absolutely.
valuable. All right, folks, let's call it. Thanks, everyone. See you next week.
Thank you. Bye.
Thank you. Bye.